Hey guys, BuildZoid here, and today we're going to be taking a look at a bad DDR5 overclock. The memory timings are very low, and so is the performance, because memory timings are like a very small part of the equation that makes up RAM performance. And a lot of people don't seem to understand that, so I've made this video to prove a point. What's the setup? The motherboard I'm using is a Gigabyte Z690 Aorus Master. The CPU is an i5-12600KF. Thank you, patrons, for the CPU. Oh, thanks to Gigabyte for the board. The memory kit is a engineering sample Gigabyte 2x16 6200 CL42 memory kit. It uses SK Hynix 16 gigabit M-die memory chips. So yeah, thank you, Gigabyte, for the board and the memory kit. And that's kind of it in terms of the hardware. I mean, there's a GT1030, but we're talking about memory here, not the GPU. Like, the GPU's job here is to put out an image. So anyway, let's take a look at the actual settings. So as you can see, the primary timings are very low, because what I basically decided to do with this setup was put the restriction on myself that none of the primary timings can be equal to or greater than 30, and so that's how I ended up at 5200 megabits per second, CL24, TRCD29, TRP29, TRAS28, and a command rate of 1T, which isn't actually 1T because the memory controller is of course running in Gear 2, and so it's technically like the thing about running 1T in Gear 2 is that the memory controller is holding a memory command for one memory controller clock cycle. But because the memory controller is clocked at half the memory, that ends up being 2 memory clock cycles. So in Gear 1, when the memory controller is at the same frequency as the memory, one memory controller clock cycle is the same as one memory clock cycle. In Gear 2, one memory controller clock cycle is actually equal to 2 memory clock cycles. And so 1T in Gear 2 is not the same as 1T in Gear 1. It's not really that big a deal. It's just something I think people should be aware of. But anyway, so the primary timings by DDR5 standards are extremely tight, and even by DDR4 standards, they aren't really that bad, because things like this exist. This is a G.Skill Hynix DJR-based memory kit. It's 5333 megabits per second, CL22, TRCD32, TRP32, and a TRAS of 52 at 1.6 volts. Also, please do not, please do not buy memory kits like this, okay? I have a lot of Hynix DJR. You don't really see me make a lot of content with it because I've never figured out how to get it to not suck at performance. It's very good at making, like, massive clock speeds and absolutely useless in benchmarks. I think it's good at Geekbench, and that's about it. So the funny thing about this is you might point out, like, oh, but the cast latency is lower than what you're running on that DDR5 setup. Yeah, the thing is, the cast latency timing is actually less important to overall performance than the TRCD timing. So 24, 29, 29, 28 is actually better than 22, 32, 32, 52. The 52 isn't really that relevant to that. That's like the TRAS timing, that doesn't make that much of a difference. But the TRCD, this is a very important timing. This timing is the reason why Samsung B-Die for DDR4 is so dominant in terms of performance, because nothing else gets even well, okay, that's not true. The Micron Rev B memory chips can get pretty close to like B-Die levels of TRCD, especially at very high clock speeds, but yeah, other than that, like, low TRCD is what makes B-Die so freaking good. So timings of 24, 29, 29, 28 are better than 22, 32, 32 because TRCD is more important than cast latency. So having 3 ticks lower TRCD is better than having 2 ticks lower cast latency. Anyway, so, you know, the point of this memory setup right here was basically pretending that DDR5 is DDR4. Which is dumb. And the reason it's dumb is that the performance is actually kind of miserable. At this point in time, it is very possible to get sub 55 nanosecond memory latency in IDA on DDR5 while hitting read speeds of over 100 gigabytes per second. Like, if you have a motherboard like a Unify X, you should have no problem hitting like 52 nanoseconds of latency. If you have a if you have a board that can do 6,000 to like 6,200 megabits per second, you should easily be able to hit 53 nanoseconds of latency. So, 58.7 nanoseconds of latency it's pretty horrible. The same goes for the Intel memory latency checker. Like, this is nowhere near the lowest memory latency that you can get out of a DDR5 setup. Yeah, so, like, yes, the timings are incredibly tight, but what a lot of people don't realize about memory latency is that it's not just about how quickly data gets from the memory stick to the memory controller. Once it gets to the memory controller, it somehow has to get to the CPU cores. And if your memory controller is clocked really low, that takes longer, right? And at 5200 megabits per second, our memory controller is doing 1300 megahertz, because the memory is running at 2600 megahertz, and then the memory controller is at half that. So the memory controller is currently running at 1300 megahertz. Maxed out DDR5, you can regularly run the memory controller in sort of the, you can be approaching like 1500 megahertz is very doable. Yeah, I screwed up on the math a bit in my head. 1500 megahertz is very doable. That's just 6,000 megabits per second. And up to like, I think 1700 megahertz is still... Yeah, 1700 megahertz is very doable on the memory controller clock with DDR5. So running your memory controller at 1300 megahertz, even if your timings are incredibly low, is bad for your overall system latency because it takes forever for the data to get through the memory controller. It's one of the main reasons why DDR4 has a massive latency advantage, is that in Gear 1, a 12th gen CPU with DDR4 is easily capable of memory controller clocks of 1900 megahertz or higher, right? So... yeah, that's kind of what's going on here with the memory latency, is just like, yeah, timings are low, but so is the actual memory controller clock, so the overall latency is terrible. And the memory bandwidth is low because the memory speed is low. Like, there's really, like, the memory speed is very easy to understand. There's no weird interactions going on there. If your memory is clocked low, your bandwidth is going to be low. I mean... You can also be clocked very high and have terrible timings, and your bandwidth will still be low, but that's not the case here. Like, these timings are about as tight as they're going to get. And you can still, and even at like 6800 megabits per second, you're not really giving up any like timing performance. So, yeah, this is just a bad memory overclock. Please do not do this to your DDR5. Like, I don't care that you think CL24 looks cool. It doesn't perform well. I did run a memory stress test. I'm just mem test. I didn't run all the other usual stress tests I do, because the thing is, like, you shouldn't run this, in my opinion. Like, I wanted to check that, like, hey, is this, even remotely viable? Is, like, yes, it is viable. Should you do this? No, you should not do this. This is bad for performance. And the real kicker, in my opinion, for this being terrible is once you see the voltage requirements. So let's go take a look at the kind of BIOS settings I need to run in order to get this to work. Because low timings do not... Well, I like to say that you get memory timings for free. Like, memory speed is difficult because it's taxing on the memory controller and the motherboard and the memory sticks and just everything. Like, so getting high memory speeds is generally pretty difficult. And then once you're at a high speed, tightening the timings is pretty easy. But if you decide to just tighten the timings at a low speed, you very quickly find out that you need stupid amounts of voltage to hit those low timings. And so that's what we're looking at here. And yeah, I don't have the CPU maxed out. And, clocking the CPU higher would probably bring down the idle latency a little bit, but not that much. But anyway... The thing is, I'm on the air cooler, and I couldn't be bothered to, like, dial in the voltages, so I just clocked the CPU really low. So everything looks reasonably, like, good, right? System agent is very low because the memory controller is at 1300 megahertz, so you don't need a lot of system agent voltage. VCC in is I bumped it up to 2 volts just because it can help with memory overclocking sometimes, and there's really no harm in running it at 2 volts. Arguably, it might actually improve the efficiency of the VCC in VRM, as it needs to supply less current to the CPU. Anyway, below that we've got VDDQ. Oh, actually, this is a really dumb thing with Gigabyte boards. So on most motherboards, you'll have a separate like VDDQ TX setting, which is an internal memory controller voltage rail. And yeah, so that exists. Now, on Gigabyte motherboards, you don't get a separate setting for that voltage. It's just tied into this setting called DRAM VDD/VDDQ. So this is setting the VDDQ TX voltage to 1.35 volts right now. That's what I'm using it for. Because the thing is that VDD/VDDQ setting, if you left your VDD2 voltage on auto, it would also set your VDD2 voltage. And if you set the voltages for your memory, leave the memory voltages on auto as well, it'll also be setting your memory voltages. But you can override that by just punching in manual values for the VDD2 and the actual memory VDDs. So VDD2 is at 1.56. This is perfectly safe for the memory controller. Like, I'm not concerned about that. It's a lot of VDD2, but it's really not going to harm the CPU in any way, shape, or form. And then we get to the memory. Now, it is worth noting that these Gigabyte memory sticks use a Renesas power management IC, and that has like a really the IC basically undervolts the memory. Once you go above 1.435 volts, it basically has a really nasty negative voltage offset. So in order to hit 1.57 volts, I need to set it to 1.64. So the memory is not actually at 1.64 volts. If it needed 1.64 volts, I would not be showing you these settings because that's a bad idea for long-term use. It's probably not that bad an idea, but like we are up there. We are basically at as high a voltage as I'd be willing to tolerate for long-term use. With this much memory voltage, you definitely do need a fan pointed at the memory sticks as they will get very hot. And also if you're trying to run very low timings, the operating temperature of the memory stick is going to affect the stability quite drastically. So yeah, the biggest problem, in my opinion, with this memory overclock is not just the performance is low. You need so much voltage to get this to even run. With this much voltage, you could easily be doing like 6800 CL32 or something, or lower if your memory sticks are really good. And here we are at 1.57 volts, 1.56. The Renesas PMIC is kind of annoying to work with, but so we're at like 1.56, 1.57 volts, and we're getting like almost 60 nanoseconds worth of memory latency. Like, it's just bad. Like, you just shouldn't do this. Anyway, let's take a look at the memory settings. So, like the actual memory timings, which again, the primaries are 24, 29, 29, 28. TRC isn't real on Intel CPUs, as in like there's not a register for that. TWR is the same thing, that doesn't exist. TCWL is at 16, so you can actually, so this is something that somebody else noticed, and I sort of decided to experiment with it on this setup right here. You can run really low TCWL on some DDR5 memory kits, so that's kind of neat. Yeah. On a lot of DDR4, you would generally be running your TCWL pretty close to your TCL, but with a lot of DDR5, you can actually drop the TCWL way down. So that's at 16. I don't even know if that's as low as it'll go. That's just kind of where I decided to arbitrarily stop. TRD, S, and L are both at 4. These do not go lower than that. Then we get a bunch of timings that do not actually exist on Intel CPUs. TRFC is bugged out on Gigabyte motherboards. You need to use the TRFC 2 setting instead, so just ignore that setting is available and use TRFC 2. TRFC per bank is your, per bank refresh. That can generally go to around 2, I like to set it at 100 below the TRFC 2. That generally works. It might go lower than that, but I'm not too fussed about dialing that in. TRTP also doesn't exist on Intel CPUs. Then we get TFAW, which is at 16. Also, I don't know if Gigabyte fixed this because I just don't use that setting, but on some BIOSes, if you try to set the TRTP, the motherboard won't be able to post. So best to leave that one on auto, in my opinion. TFAW is at 16. This doesn't go any lower than that. Command rate is at 1. Also doesn't go any lower than that. You can't set it to 0. TREFI is at 65,000. It doesn't go any higher than that on Gigabyte boards, which is a bit unfortunate because the 12th gen memory controller does actually have a TREFI register that goes all the way up to like 262,000, which can improve the memory latency a bit, though in my experience, if you push really, really high TREFI, it can cause some weird performance issues sometimes. So at 65,000, I've never run into any issues, but 260,000 is kind of like, I use it for benchmarking. I don't really use it for anything else. TXP is set to 4. This doesn't go any lower. It gives you a nice little memory latency improvement, and it also generally doesn't cause any stability issues in my experience. Then as we keep going down, we get TWR PDEN and TWR Pre. These are set to 32. This is pretty low for these two timings. It's not the lowest, but it is quite low. TRD Pre is set to 12. This is the timing that actually sets the RTP up here. So you can see the RTP's at 12. That's because RD Pre is at 12. Yeah, and the TWR timings are the TWR PDEN, TWR Pre are the timings that are setting the TWR to 12. If you manually try to set TWR, you can't go below 48. So yeah, might want to be. So that's the other reason, like, to set these two down here instead of TWR itself. TCK is at 4. It doesn't go any lower than that on Intel CPUs. And then we get to the tertiaries. And I will say I'm kind of, like, what is kind of interesting is that at 5200 megabits per second, you can actually run, like, a TRRD SG of 10. Maybe even 9 would work, but I've not been bothered to test it. It also wouldn't, like, these timings primarily just boost your memory bandwidth a bit, and I can't be bothered to test that very much. These two do not go below 17, which is very unfortunate. Like, I tried 16, it doesn't post. This might go lower, but I didn't try, so that's at 9. Normally, this is as low as, like, if you're at reasonable DDR5 speeds, 9 is usually as low as you can set the write-to-write same group. Different group doesn't go below 7. Then we get to write-to-read same group and different group at 44 and 36. This is very low compared to what you normally need to use at, like, 6,000 megabits per second and up. But these definitely change with the memory speed you're at, but at higher speeds you just are faster. So the fact that these two are really quite tight doesn't really, like, it doesn't fix the performance. And that's it for the timings. Everything else is on auto, because then we get a bunch of round-trip latency timings, which if you try to change these manually, it won't post. Then we get the termination settings, which I've just not tried to mess with whatsoever with DDR5 so far. So yeah, that's the settings. I guess for fun we could try an, you know what, let's try an IDA with, like, really high cache and CPU clock to give it the best chance of, like, not being terrible. The air cooler is going to hate me for this. I also have fast boot disabled, so it's going to go through the full memory training, but that doesn't really matter. Like, the biggest problem with the air cooler is that it's actually just sitting there. Like, it's not properly mounted to the motherboard, so... Oh, and it failed to train for some reason. I should have just turned fast boot back on. So this might even have retrain stability issues. To make things really bad. Like, not only is the performance low, and it needs a ton of voltage, but it also doesn't seem to be particularly stable. Because it did just fail to train. So, anyway, let's do one more run of IDA, but this time at 5.1 with 4.8 ring. This should generally, like, at 5.1 core, 4.8 ring, and yeah, the air cooler is going to be very upset about this. Because the thing is, with it not being mounted down to the CPU, also the CPU is lapped, whereas the air cooler is very curved. So this is really suboptimal. But anyway, like, the thing is, a lot of memory... Well, an annoying fact of, like, all memory benchmarks is that they're all somewhat CPU bottlenecked. So you can actually see that the read speed has improved, partially probably because I've run it after, like, before running all of the stress tests. Like, generally, if you want to get a good score in IDA, you should run it first thing after turning the system on. If the system's been running for a while, IDA's performance just goes straight to hell, yeah, so, but we still get 65. That might be because I have the temperature monitoring. Anything pulling the hardware while you're running a memory latency test is going to be very bad for the memory latency test. Like, memory latency tests are unfortunately extremely sensitive to other things running in the background. So if you want accurate memory latency results, like, you need to basically turn everything off. So yeah. So if you have a, like if you're running, if you have memory settings that you feel should be getting a good memory latency result, but they aren't, yeah, so now we get 57.5, which, like, it's a lot better than if you had your DDR5 on JDEC, because I think JDEC on this motherboard hits like 65, 70 nanoseconds, something like that. It's pretty terrible, but, like, in the grand scheme of DDR5 memory overclocks, 57.5 nanoseconds of latency really is not great. Yeah. So, like, the one use case that this kind of configuration for the memory does have is if you're on, say, a motherboard that really struggles with hitting high memory speeds, then yeah, it could make... Well, the thing is, no, even if your motherboard just can't do like 6200 megabits per second or 6000 megabits per second, instead of trying to do something dumb like this, you should just do like 5800 CL28, 26 might work. Actually, with this much voltage, 26 probably would work at 5800. So you could go for something like that. And you'd get better performance, because like you really do need the memory controller to like be clocked relatively high if you want good performance. I have a sneaking suspicion we're hitting the thermal limit. Let me just pull up core temp. There's also a chance that the read speed boosted in IDA because IDA has a bad habit of hitting the L3 cache instead of the memory. Also, you can see the impact of me opening up core temp on the latency result right there. Right, like, because as like Intel memory latency checker runs, the memory latency should basically be consistently coming down. So you can really see that, like, yeah, opening up core temp and it added 2 nanoseconds. So that's why if you're running any kind of memory latency test, you really need to have a relatively clean system. Like, this isn't the cleanest operating system I have, but there's not a bunch of RGB crap on there. I'm not running a bunch of hardware monitoring utilities all the time. Well, not unless I choose to run them, but I don't run them at the same time as running a memory latency test because that sends the memory latency test straight to hell. Yeah, anyway, so, like, it's not, it's not the worst memory latency you can get out of DDR5, but if you've got a SK Hynix-based DDR5 memory kit, don't do this. This is a waste of time. Yeah. But anyway, for all the people who want their DDR5 to have DDR4 style timings, this is what happens when you try your DDR5 with DDR4 style timings. And that's it for the video, so thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comments section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There is a link to that down in the description below. Then there's also the AHOC Teespring store. There's a link to that down in the description below as well. So Teespring store is like shirts, hoodies, posters, usual YouTuber merch. And then there's the... oh, right, and I have a Bandcamp. If, like, for some reason you hate your ears, you could check that out. There's a link to it down in the description. So, yeah. That's it for the video. Thank you for watching, and goodbye.